Welcome to Astronomy Daily, your go-to source for the latest and most fascinating space and astronomy news. I'm Anna, and I'm thrilled to be your host for today's cosmic journey. We've got an exciting lineup of stories that will take us from the depths of our solar system to the brushstrokes of a famous painting and even to the cutting edge of radio astronomy. We'll start by exploring new research that's changing our understanding of the dwarf planet Ceres. Then we'll dive into a controversial theory about the moon's origin that's challenging long-held beliefs. We'll also look at upcoming space launches, uncover the surprising physics behind Van Gogh's Starry Night, and explore new findings about the moon's interior. Finally, we'll check out China's plans to expand the world's largest radio telescope. So, buckle up and get ready for a thrilling ride through the universe. First up today, astronomers have made a groundbreaking discovery that's changing our understanding of Ceres, the largest object in the asteroid belt. New research published in Nature Astronomy suggests that this dwarf planet may have once been an ancient ocean world, much like some of the icy moons in the outer solar system. For years, scientists believed that Ceres had relatively little ice, with estimates suggesting less than 30% of its composition was icy. However, this new study proposes that Ceres might actually be composed of about 90% ice, with a history that includes a muddy, ocean-covered surface. Using computer simulations, researchers examined how the craters on Ceres' surface might have deformed over billions of years due to the presence of water. They found that by mixing just a small amount of solid rock with ice, the surface could maintain its cratered appearance over long periods, even with a high ice content. This revelation paints a picture of Ceres as a dirty snowball rather than a rocky body. It suggests that in its ancient past, Ceres may have been similar to Europa, one of Jupiter's moons known for its subsurface ocean. The difference is that Ceres' ocean would have been muddier, filled with various minerals and impurities. What's particularly exciting about this discovery is how accessible Ceres is compared to other icy worlds in our solar system. Located in the asteroid belt between Mars and Jupiter, Ceres is much closer to Earth than the icy moons of the outer planets. This proximity makes it an attractive target for future space missions aimed at studying ocean worlds and the potential for extraterrestrial life. The bright features we see on Ceres' surface today might actually be the remnants of this ancient ocean, now frozen and erupted onto the surface. This opens up tantalizing possibilities for future exploration, as these areas could provide valuable samples from an ancient ocean world right in our cosmic backyard. Now let's turn our attention to a fascinating new theory about the moon's origin. While most of us are familiar with the idea that the moon formed from a collision between Earth and a Mars-sized object called Theia, a new study is challenging this long-held belief. Researchers from Penn State University have proposed an alternative theory. The moon might have been captured by Earth's gravity, instead of being born from a catastrophic impact. This capture theory suggests that the moon was originally part of a binary pair of rocky objects that had a close encounter with our young Earth. One of the key pieces of evidence supporting this idea is the moon's orbit. It's aligned with the plane of the ecliptic rather than Earth's equator, which is what we might expect if it formed from a collision. This orbital alignment is more consistent with a capture scenario. The researchers point out that we've seen similar captures elsewhere in our solar system. For example, Neptune's largest moon, Triton, is thought to have been a Kuiper belt object that was pulled into orbit by Neptune's gravity. Using complex calculations, the team demonstrated that if Earth had captured the moon, its initial elliptical orbit would have been altered by tidal forces over thousands of years. This process would have resulted in the more circular orbit we see today. Interestingly, this capture theory doesn't necessarily explain how the moon formed in the first place. It just offers a different explanation for how it became part of our Earth-Moon system. While this new theory is intriguing, it's important to note that the giant impact hypothesis still has substantial evidence supporting it, including similarities between the moon's composition and Earth's mantle. As with many aspects of space science, more research will be needed to fully understand the origins of our celestial companion. Now let's take a look at some exciting upcoming space launches that are set to take place in this week. First up, we have the United Launch Alliance's Vulcan Centaur rocket preparing for its second flight. This mission, known as Certification Flight 2, is crucial as it will complete Vulcan's certification process with the U.S. Space Force. The launch is scheduled for Friday, October 4th from Cape Canaveral Space Force Station in Florida. While the original plan was to carry Sierra Space's Dream Chaser Tenacity, the payload has been replaced with a mass simulator and various experiments. Moving on to SpaceX, the company has had to adjust its launch schedule following an off-nominal deorbit burn of a Falcon 9 second stage. As a result, a planned OneWeb mission from Vandenberg has been pushed to next week, while a Starlink mission is now set to launch from Cape Canaveral on Saturday, October 5th. But perhaps the most intriguing upcoming mission is the European Space Agency's Hera, set to launch on a SpaceX Falcon 9 rocket. This mission will study the results of NASA's double asteroid redirection test, which successfully impacted the Dimorphos asteroid 2 years ago. Hera will carry 2 CubeSats and is scheduled to lift off on Monday, October 7th from Cape Canaveral. The Hera mission is particularly fascinating as it will provide crucial data on asteroid deflection techniques. After a 2-year journey through space, including a Mars flyby, Hera will reach Dimorphos to investigate the impact crater left by DART and study the asteroid's composition in unprecedented detail. These launches represent the cutting edge of space exploration and technology, from rocket certification to planetary defense. It's an exciting time for space enthusiasts, and we'll be sure to keep you updated on these missions as they unfold. Let's move on to something a little different. Vincent van Gogh's The Starry Night is not just a masterpiece of art, but also a surprisingly accurate depiction of physics in action. Scientists have discovered that the swirling patterns in the night sky of this iconic painting actually follow the laws of fluid turbulence. The eddies and swirls that Van Gogh painted align with Kolmogorov's law, a theory that predicts how energy moves in turbulent fluids. This law describes the patterns we see in everything from the atmosphere to ocean currents. It's astounding that Van Gogh captured this phenomenon in his art, decades before it was mathematically described. But that's not all. The painting also exhibits what's known as bachelor's scaling, which relates to how small particles, like pigments, diffuse in a turbulent flow. This is visible in the way Van Gogh applied his paint to the canvas. While we don't actually see such dramatic swirls in the night sky with our naked eyes, Van Gogh's artistic interpretation eerily mirrors the invisible turbulence present in our atmosphere. It's a fascinating blend of artistic vision and scientific accuracy, showing that sometimes great art can reveal truths about our universe that we're only just beginning to understand. Now let's return to our moon and dive into some fascinating new discoveries about the moon's interior. Recent gravity measurements have revealed something unexpected beneath the lunar surface, a potentially partially molten layer in the moon's mantle. This finding comes from an analysis of lunar tides. Just as the moon causes tides on Earth, our planet's gravitational pull also affects the moon, causing subtle changes in its shape and gravity. By studying these tidal effects, researchers can gain insights into the moon's internal structure. Using data from NASA's Grail mission and the Lunar Reconnaissance Orbiter, scientists have detected both monthly and yearly changes in lunar gravity. When they plugged this information into computer models, they found that including a softer, partially molten layer at the base of the mantle was necessary to explain the observed measurements. This discovery could have significant implications for our understanding of the moon's structure, origin, and evolution. It raises questions about the heat source maintaining this partially molten state over billions of years, and may provide new clues about the moon's formation and early history. While more research is needed to fully understand this layer, it's an exciting reminder that even our closest celestial neighbor still holds many mysteries waiting to be unraveled. Finally, today, China is taking its already impressive 500-meter aperture spherical telescope, or FAST, to new heights. The world's largest single-dish radio telescope is about to get even more powerful with the addition of 24 new movable radio telescopes, each measuring 131 feet in diameter. This expansion, dubbed the Fast Core Array, will take advantage of the telescope's quiet electromagnetic environment. By combining these new dishes into an array, scientists will significantly enhance the resolution and detection capabilities of FAST. The goal is to enable deeper investigations into fascinating cosmic phenomena, like gravitational wave events, fast radio bursts, supernovae, and black hole tidal disruption events. It will also contribute to space situational awareness, detection of small solar system objects, and even assist with deep space probe communication. Since becoming fully operational in 2020, FAST has already detected over 900 pulsars. With this upgrade, we can expect even more groundbreaking discoveries. It's an exciting development that promises to push the boundaries of our understanding of the universe. And that wraps up our cosmic journey for today. We've explored the watery past of Ceres, pondered a new theory about the moon's origin, and looked ahead to exciting space missions. We've even seen how art and science intersect in Van Gogh's masterpiece, delved into lunar mysteries, and marveled at China's expanding radio telescope. If you're hungry for more space news, head over to our website at astronomydaily.io. There, you can sign up for our free daily newsletter and catch up on all the latest developments with our constantly updating newsfeed. You can also listen to all our past episodes. Don't forget to follow us on social media. Search for Astro Daily Pod on Facebook, X, YouTube, and TikTok to stay connected with us between episodes. This is Anna signing off. Keep looking up, and we'll see you next time on Astronomy Daily.